Hey guys, and welcome to part 8 of making an HTTP server in Java. In the last part we left off while making a test case where we were checking a request to see if it had no line feed. We ran that test and it gave us the right result, but for the wrong reasons, because we never, in fact, in the code, check for a line feed. So that got me a little bit confused why we were getting the right result. So I decided to investigate a little bit and then do the code to do exactly this check, just to make sure that we catch it all the time. So this is the method we have been working on, and I start off by creating a debug breakpoint and running this in the debugger. We are calling the HTTP parser, and I'm just going to step through each call that I'm making. So that's the generation of the request, and this is the parsing of the request. So now we start reading the request, and what I really want to see is what happens when we find a carriage line. So when we find it, we get to the byte reader, and the next byte, it's not a line feed. So it continues. So I know for a fact that at this point, the parser thinks everything is all right, because this method pass is false, so we don't catch it there, and we continue to iterate the bytes. So we need to do something at this point. So let's stop the debugger, because we don't want to have this running, and let's write what happens if the next byte after a carriage return is not a line feed. And if it's not a line feed, what we want to do is just throw an exception. In this case, a HTTP parsing exception, which is a bed request. So let's give it a run now. And all the tests pass. So it's perfect now. We are accounting for everything, and we just remove the breakpoints so that it's clean for the next debug session. So let's collapse all this so it's a bit neater. And let's talk about the next part that we are going to do. We already find the request target, but we are not assigning it to the request yet. So let's do that now. Let's go to the parse HTTP request. Let's create another assert line. So we set equals the request.get request target, which we don't have yet, but we'll create in a minute. And let's just make sure that it matches this, the slash. And we might as well just make an assert not null to the request over here, just to make sure that we catch that before anything else. Now let's go to the HTTP parser and the place where we find the request target. And let's just assign this to the request, again using a setter that doesn't yet exist. So set request target, and let's pass it the data that's on the data buffer. So now let's create the set request target. And it basically sets the property that we have here already. So this request target equals, let's just change this name to request target. That's it. And let's just make sure that the request target that we are providing, it's not null and it's got some length to it, or else we're just going to throw a parsing exception. We're just going to say that's an internal error for the time being, and let's make the method throw this exception. Perfect. Let's leave it package level, and now let's create the getter for the request target. Now there's still some error here. Oh no. So everything is cleared. Let's give it a run. And everything passes. Perfect. So now let's do the same thing to the version. But the version is a little bit more complex. It has some structure to it. So let's just quickly check out the RFC. And we can see in RFC 7230 under protocol versioning that the HTTP version is basically HTTP slash a digit dot digit. So it's basically 2 decimal digits separated by a dot, a period. Okay, the first digit is the major version and the second digit is the minor version. If you want to get more into the nitty-gritty details, just give it a read at the RFC. It's quite straightforward. Another thing I want to point out is this small detail, which is that a server can send a 505 code if it doesn't want to service a client's major protocol request. So nothing special about this, is just a small detail that I want to point out. And also have in mind that this simple HTTP server, it's not fully compliant. It's just a small exercise that we are doing, and to make it really fully compliant, you would need to read through the RFC completely and have a fairly good understanding of everything that you needed to implement. So let's go and create another class. Let's call it HTTP version, and let's make it an enumeration for the HTTP versions that we want to support. And we are just going to support 1.1, so let's create the 1.1 enum value, like so. And let's create the entries. So basically a string called the literal, which is going to be the literal value that we are looking for on the request string, on the HTTP request. And 2 integers, which are going to be the major and the minor, like this. Now let's create the constructor and we pass that in, and let's just define the values over here for that value. So HTTP slash 1.1, and the major is 1 and the minor is 1, and that's it. So now let's just create a very simple util method, which is going to get the best compatible version for a literal version that gets provided. And for that, we are going to use a pattern. Let me just fix this static. Okay. And let's import the regex pattern. Perfect. And we are just going to call it HTTP version regex pattern. And let's compile a pattern for it. So it starts with HTTP followed by a slash, and then we are going to have a digit which we are going to name major, and D, which is digit dot minor, also a digit, so like this. Perfect. Now let's use a matcher to see if the literal string that is provided as an input matches everything that we want from our pattern. So let's just create the matcher from that pattern, and then let's ask the matcher if it actually finds things. Well, if it doesn't, we'll do it the inverse. If it doesn't find, or if it finds it but the group count that we find is different than 2, then at this point we have a problem. We know we have a problem. So we'll just throw a new HTTP parsing exception, and for the time being I'm gonna say it's a 500 exception, and I'll just create a comment over here just to revise this later. We want to change this to a 505 so I don't forget, but I'm not going to create this exception right now, so let's just move on. Okay, some small fixes. Perfect. And now I'm going to extract the minor and the major. So the major first, and we use an integer parse. And we go to the matcher, and we get that group. which we named major. Let's copy this and do the same for the minor. Minor. Cool. So the way we're going to do this is using a for loop, and the reason we do this is because we want to find the best compatible version. So let's iterate all the versions that we support, which is basically all the versions defined in this enum class. And just for a quick check and to get everything out of the way, we'll just see if the version literal, of the enum matches exactly the literal version of the input. If that matches, then we support fully that version and we just return the version straight away. But if it doesn't, and this is what this else is for, what we do is we need to start comparing the major and the minor versions. Okay, so let's create this temporary variable called temporary best compatible, and we'll set it to null. Cool. And now let's start comparing. First, we compare the major. So if the version that we are looking at right now, if the major is exactly the same as the major provided on the literal, then we do more work. So now we check if the minor version is smaller than the minor provided in the literal from the input. And if it is smaller, then this version is compatible. So we just assign that to the best compatible temporary variable. Yeah. And because we are going to create the enum in order, this is always going to work. We're going to get the best version because the best is going to be the last. Just a small note, a small correction. That exception over there, the 500, I said that I wanted to send a 505. I'm not completely sure. The 505 is just that if we find an incompatible version, what we are checking over here is that if the string that we get does not represent a version. So a 500 is probably the more indicated error code that we want to send. But let's not deal with it over here. Let's just create an exception for bad parsing of the version, so a bad HTTP version exception, like so. Just fix this. Bad. Okay. Let's just extend from exception. Perfect. And let's replace that parsing, that bit over here, with this exception. Let's not send any code. Replace that, and let's just remove this comment. We'll deal with this in the parser. Now let's create a class for JUnits on this class. So HTTP version test class. Perfect. And I know you're probably thinking, oh my god, every time we do anything we have to do a JUnit, and yes, that is true. We want to be doing JUnits all the time. This is what will make our code work when we start fiddling with issues in the future. We just create a lot of JUnits, and this way we can make sure that everything keeps working as we do changes. Let's create this method, the get compat version exact match, and let's just try to see what happens when we call the HTTP version, that method that we just created, the best compatible version, and we just give it a string literal that actually matches one version that we have there defined. So let's set not null first to see that we got a version. Okay, version. And let's set that it matches exactly. So it's equals the only enum version that we have over there. Now let's try catch around this. And in case we get to this, it's obviously a fail. So let's just save this and give it a run. So let's just create this execution over here. We are doing a class kind of test. So let's just run it. And everything passes. Perfect. But this was the easiest scenario. Yeah. We coded specifically for this. So now let's create another test method, and we are going to try to see what happens when we do a bad request, a bad version. So let's call it bad format. And if we call this and an exception is not thrown, so if we go through to the first line, then we fail straight away. Let's change this to a lowercase. And let's give it a run just to see what happens. Perfect. So we are getting an exception. So now let's create another method and let's give it a higher version. Let's fix this bit over here. Let's add the assertions as well. And move the fail to the correct spot. And perfect, it works as well. So if we give it a higher minor version, what happens is it is just basically telling us that the best compatible version is version 1. Let's continue working on the parser now. And let's go straight away into the HTTP request so we can do some changes. So we were storing the HTTP version as a string, and now we want to rename this to original HTTP version. And the reason is this is what we get from the request. We're just going to store it so that we have it here for some reason later on. And now we are going to create another variable, a private HTTP version variable, which is the best compatible version for this request. So HTTP version and best compatible version. Perfect. Let's just collapse these methods so that it's a bit neater. And let's create another method to this time do a set of the original HTTP version. Let's rename it to just set HTTP version, like so. And we are not only going to just be setting the original HTTP version variable, we are also going to be setting the best compatible HTTP version. We are going to do that by calling the HTTP version method get best compatible version, like so. And we pass the original literal, like this. And now, because this throws an exception, we also add that to the list of exceptions this method throws, and we check to see if the returned best compatible version is null. If it is null, then there are no compatible versions to work with, so we throw a new exception, an HTTP exception, and the code that we are going to use is the one that we checked on the RFC, the 505. So let's just add this, use this as a template, rename this to 505, and call it HTTP version not supported. Let's just create the enum. So this didn't work. Let's just create the enum over here. 505. And HTTP version not supported. Perfect. So now let's go back to the HTTP request and add this as well as an exception that this method can throw. So add it to the signature. And now let's go to the parser again. And let's just scroll up a little bit. And over here, after we find the line feed, we are just going to update the request with the HTTP version. So we'll just use the data buffer. Let's just try catch around this. And when we get this bad HTTP version exception, we just we just throw a parsing exception, and we send 400 bad request code. Let's update the test configuration that we are using. So let's create another one actually. And we are just going to run all the tests in this project. And let's rename this to all tests. Perfect. Let's apply and OK. And let's run them. And all tests passed. Perfect. And now let's create a few more JUnits on the HTTP parser so that it can account for these HTTP versions. So the first one, let's create a generator for a bad HTTP version, so a bad format. So let's just call it generate bad HTTP version request. And let's modify the HTTP version, so just a T or something. Okay, so this is good. Let's create the test method. So let's copy from this one. Let's change the name. Bad HTTP request. HTTP version, sorry. Let's call the generate that we've just created. So where is it? Over here. So if the parser passes the message with no exception, we fail. And if we get an exception, let's just compare what the error code is. If it is a 400 bad request, let's call it and run, and all is good. Let's now do another one for an unsupported version. So copy this generate. Let's fix the name of it. So unsupported. Let's fix this version and let's call 2.1. Let's rename it to unsupported. Call the new generate. And let's give it a quick run, which we know that it's going to fail because it's not a 400 bad error code. So let's fix that now. Change this for a 505. Let's give it a run. And all is good, just as expected. And now let's create another test case, but this time for a supported version. But let's give it a version that's higher than the one that we've got, so that we need to fall back to our version. So let's change the name of this method, of the generate method, to supported. And let's change this to 1.2. Perfect. Let's copy the test method. And let's change the name of it. Perfect. And let's remove this fail because we are supposed to pass this, and we fail if we get an exception. And not return, but assert that it's not null, the request. And now we assert that the version that we get from the request. And so I noticed that we just completely forgot to create the getter. So let's take care of that now. So let's go for the message, the request, sorry. And let's create a getter for the HTTP version. So let's just generate that. Perfect. Let's go to the unit test again. Perfect. Let's give it a run. And all passing. Perfect. We might as well just do another assert just to make sure that the original version literal is the same. So let's create this getter as well. Let's compare to what we have. So HTTP / 1.2. Yeah. Run. And all is good. Let's collapse everything so it's tidier. Let's update the parse HTTP request so that we not only check the request target, but now we are also going to check for the version. So it's just a small increment on this test. So the original version, so that we compare the literal. Nice. And we also assert for the HTTP version object. So get the best compatible and make sure it's 1.1. So let's give it a run. And again, also good. So I hope you stuck around. This was a pretty long one and very boring, I know, just unit cases. But on the bright side, now we have the complete request line all parsed and assigned to an object that represents our request. On the next video, we are going to be parsing the headers of the request, so it's going to be a little bit more like this. But then we have everything that we need to process a request and just go to the file system, get the files, deliver it to the browser or whatever client is connecting to our server. So again, I hope you enjoyed and see you on the next video.